Hi again.
Good morning, guys.
How you doing? All right. We got the metric system here, which is known as Le Système International.
How'd the French sneak in on us? Weren't we just talking about a Brit?
It had something to do with Napoleon, I think.
Okay.
He's the dude who started working on the organizing a metric system to make things easier.
Are we like the only country that doesn't do the metric system?
I think last time I checked, we're one of like 5.
Jeez.
The other 4 are extremely tiny islands.
Yeah.
So, yeah, we're the only major country that doesn't do the metric system.
All right. SI for short sounds good.
SI. Okay, so we use, in the metric system, we use mass, length, time, and temperature. The kilogram, the meter, the second.
So these are SI units,
yep.
Yeah? Okay.
Abbreviations, kilograms, meters.
Seconds and Kelvin.
Yeah, I think we talked about this earlier.
Yeah, a little bit, yeah.
Okay, so this is repetitious, but it's science. So.
Well, they need to know the SI units anyway. Ooh, metrics.
Okay, metric prefixes.
Prefixes.
All right, guys, you want to press pause and you want to write all this down. The prefixes with stars are ones that Mrs. G and I decided are the important ones, and you have to memorize.
All right.
Okay, Mrs. G, there's some sort of a rhyme to do this, right? But
yeah.
I mean, if you don't know when the Illinois State Lottery calls you up and says, "Hey, you won the Mega Millions," if you don't know how much a mega is, you're probably not going to be as excited as you should be.
Mega means a million.
Right. So if they tell you you won the Mega Millions, they're literally telling you you won millions of millions. And if they don't give you millions of millions, you should sue for false advertising.
There you go. So mega means a million, kilo is 1,000.
And, okay, so mega power 10 is 10 to the 6th.
Right.
1,000, 10 to the 3rd.
Right, so what are the base units? What units would you put in for the base?
Like grams.
So grams, the liter, yeah?
Liters,
okay.
Meters. Okay, so that's a base unit.
Okay, so even
these are prefixes. These are things that go in front. So this would be like megagrams.
Okay, I
or
got it.
Kilograms. Or mega liters.
Okay.
That's how they're going to sell the big gulp in New York from now on.
Oh yeah.
The mega liter.
You'll end up in jail if you buy one. All right. So going up from the base units, those are relatively big numbers.
Yeah, times 10 to the 3rd, times 10 to the 6th, they're bigger.
Going down or smaller.
Times Oh, these are all negative exponents. Now I like to pronounce this. A lot of people say 0.1. I like to pronounce that a tenth.
Okay, 1/10 of a gram or liter.
And this is
1/100th of a gram or a liter, and 1/1000th.
Right, you can pronounce it that way, 1/1000th, because this is the tenths, hundredths, this is the thousandths. One more zero.
So technically speaking, the milli is kind of the mirror of the kilo, but in the smaller range.
Exactly. Yeah, milli and kilo are kind of related.
Okay.
And if you ever forget centi, you know what? You just don't know what your dollars and cents are.
Well, a century is 100,
right,
so that centi be 1/100th.
And a cent is a penny. How do you write a penny?
Oh, that's right, a penny. I don't have many of those.
Basically, though, a micro is a millionth.
A nano is...
Yeah, and a nano is a billionth.
Yeah. And that's actually my salary. All right, so metric prefixes. Okay, got it.
So what we've got to do is we've got to memorize that mega is a capital M, meaning a million, and its power of 10 is 10 to the 6th.
Whoa, whoa, whoa! You want me to know the prefix, the symbol, and the meaning?
Yeah.
Holy mackerel! I'm transferring out of this class.
All right, go for it. There's guidance has the slips. I'll sign off on it. Just make sure you bring it to me filled out.
Will do.
All right.
Oh, this one looks ugly. I'm scared.
Dimensional analysis. Factor label. Unit conversions.
So it's got a couple of different acronyms, doesn't it?
Yeah, different people call it different things, but it all boils down to the same thing. We're doing math.
Math, okay.
Math with unit conversions.
Math with ratios and units.
It's actually not as hard as people try and make it out to be. Everyone gets all anxiety and caught up in it, and it's really pretty simple.
Yeah, it is, as long as you follow the units and you write it right.
Yeah, it's not that hard.
All right.
All right, so basic ideas for unit conversions. You copy the number in the units. You use different factors to cancel out units and generate new units. And you repeat that step as necessary until you get to the units you want. So you're going to use different factors, like you said, Mrs. G. Factors.
Okay.
Okay. And you just do the math. So for instance, there's this problem up on the screen here.
Okay, so 4.5 kilograms. That's what you start with, right? 4.5.
So we're going to start with 4.5 kilograms.
And I want to convert to grams.
And we're just going to use ratios to do that.
Okay, and according to the metric prefixes, there are 1,000 grams in a kilogram.
Right. And the way I like to try and look at it, the kilograms up here means that I want kilograms down here.
Okay, so the bottom of the ratio will cancel the old units, right?
Right.
Okay.
And I know the kilogram is the bigger between a gram and a kilogram. I'm going to toss a 1 in there.
Okay.
And if I know my definition right, if I measured my metric prefixes, which hopefully I made flashcards on that, I've got 1,000 grams for 1 kilogram.
Okay.
Notice this all by itself is a true statement. 1 kilogram is the same thing as 1,000 grams.
Okay.
Okay, it's not actually a division bar. It's saying that these two things are equal to each other. Okay, so that means kilograms and kilograms are going to cancel because basically I've got something on top, something on the bottom.
Okay.
They cancel each other, right?
Yeah. So
grams
you
are left.
plunk that into your calculator, right? How many sig figs would you get?
I don't even need a calculator to do 4.5 times 1,000.
True.
All right, I know that it's going to move the decimal 3 places to the right, so it's going to be 4500. How many sig figs? That was the question, right?
Yeah.
Okay, well this measurement here, 4.5 kilograms, seems to have 2 sig figs, right? 1,000 grams in a kilogram, that's a special case, isn't it?
Yeah, that's one of those, we called it earlier, yeah, you don't use it to determine the number of sig figs.
So there's an infinite number of sig figs here. So I want to use the smallest number of sig figs, which is...
Not the largest, it's still going to be 4.5.
All right, 2. And this...
It is.
4,500, these 2 digits are significant, so I'm good.
Those 2 are. All right, that's easy.
4,500 grams, and I've got units on it.
They're
a little bit far away, but they're still there. Okay.
That seemed easy enough.
Very easy.
Ooh, another one.
So we start out with 0.851 grams.
All right, so start out with the number they give you in the problem. Now we need a ratio that relates grams to milligrams, correct, Mr. Kane?
Right, and I like how you said that. When you said that, the grams go on the bottom and the milligrams go on top.
Okay, so if I remember right...
Which one's bigger, the grams or the milligrams?
Grams are bigger.
Yeah, grams are bigger, so there's going to be 1 gram. And how many millis does it take to make a full gram?
Oh, and I memorized these before.
What's a milli worth?
Milli was 1/1000.
So if I've got 1/1000, that would take 999 more to make a full, right?
That sounds reasonable.
It takes 1,000 milligrams.
Yeah.
Is that how you memorized it?
Yes.
1,000 milligrams to make a gram?
There are 1,000 milligrams in a gram. That is correct.
So grams cancel. I'm left with milligrams, so I must be done. Do the math. 0.85 times 1,000. That would be 851 0 1 2 3. All right. Again, no calculator on this one.
Wow.
All right.
You are courageous, Mr. Kane.
Got to sign me up for Harvard. Let's see. How many sig figs do I have? 8, 5, and 1 is 3 sig figs. 1,000 milligrams to a gram, that's just a conversion factor, so it's got an infinite number of sig figs. So I need 3 in my answer, right?
Correct.
1, 2, 3. So I wrote this wrong because that is actually a sig fig according to how I wrote it. So I'm going to have to rewrite this and then circle it so that when you grade this, Mrs. Goswish, you don't mark me wrong.
So your answer cannot be more significant, and since it's multiplication and division, you're talking number of,
right,
correct?
We're talking number of.
All
Most of the time in chemistry, we're dealing with
yeah.
number of, not place value.
You don't include what's in the ratio, because it's an infinite, it's great.
Mm-hmm.
You just don't. Right. So your answer can't be more significant than the starting point with the problem. Okay, got it. 3 sig figs, 3 sig figs.
All right. So converting 23.2 kilograms to milligrams, I'm going to take 23.2 kilograms.
Now, wait a minute, I didn't see anything that went from kilograms that related kilograms directly to milligrams, Mr. Kane. Now what do we do?
I think we can go straight to the base units in between, because I know how many kilograms there are in a... Actually, I know how many grams there are in a kilogram.
There are 1,000 grams in a kilogram.
Yeah.
Okay.
So I can go to the base unit, and then remember the step 3 said do as much as necessary.
Yeah, because
So-
that first ratio doesn't answer the question, does it?
No, but it does get me out of kilograms. It gets me a little bit closer because I can go from grams to milligrams because I know how many milligrams are in 1 gram.
Yep, 1,000.
1,000.
So you have to do 2 ratios?
So I have to do 2 ratios. I could do 100 ratios if I had to. But the basic math here is 23.2 times 1,000 times 1,000.
Holy mackerel.
So we're going to get 23.2000000.
It's going to be a big number, Mr. Kane.
23 million?
Yep.
Okay. 23,200,000 milligrams. Now let's check sig figs. 1, 2, 3.
Don't use the ratios, right?
3, yeah. Infinity and infinity. So yeah, that's it.
Hey, can you
3.
write that in the scientific notation, Mr. Kane?
Sure, I can. Because it's kind of wordy
Big
here,
number,
right?
yeah.
So 2.32 times 10. Let's see, that's 3, 6, 7 place values.
Milligrams? That's a big number.
2.32 times 10 to the 7th milligrams. Notice 3 sig figs here, 3 sig figs there.
Okay.
So this is kind of a unique unit. We've done this once before. This unit, 1, 2, 3, 4, and 5. So those 5 problems are what we need you to do. Bring them in, have your name on them, show all the work, be neat about it.
Yeah.